welcome back to another lecture of Lux tutorial. Now in today's lecture we are going to see some few examples based on the topic that is common factors in the case of factorization. Now if you are new to this video, you must go and watch the previous two videos whose link is already present in the description box. Go there, watch out, understand the basics, and then you can easily understand what I am going to discuss over here. And if you are new to my channel, don't forget to press the subscribe button and press on the bell icon. As well as I am present in all the social media platforms that you can see in the description box. You can follow me over there also. Now let us start with this topic. So we are getting an expression over here, that is 27a cube b cube minus 18 a square b cube plus 75 a cube b square. Now in this particular expression I have already discussed what is the method that we are going to use over here. The method that we are going to use is the LCM method, or if you are very much acquainted with that method, you can do the common part, or you can take the term that is present in these three terms directly. So if you are not that acquainted, let us understand with that method, and if you are pretty much acquainted, you can start directly the expression over here, or you can find out the terms that is present, or you can take out the terms that is common in these three expressions. So first let us discuss the LCM method. So the terms that I am getting over here is 27, then 18 and then 75. So in these three terms we see that if we divide it by 3, we will get 9 over here, we will get 6 over here, and in this one we will get 25 over here. So if we divide this 75 by 3, we will get 25, 18 by 3, we will get 6, and 27 by 3, we will get 9. Apart from taking 3 common, we are not getting any terms common. Now you might ask me, sir, in the first two cases you are getting 3 common, why not to divide it by 3? Now remember that whenever you are taking common, it has to be present in all the 3 terms. It cannot be present in only 2 terms. It cannot be present in first and second. It should not be present in first and third. It should not be present in second and third. It has to be present in all the 3 terms. So we can see that 3 is present in all the 3 terms. So we are taking 3 common over here. So first thing is to write the common part, that is 3. Second thing is to understand the variables over here. And in this case, the terms that we are getting in the first one is a cube b cube. In the second one, a square b cube. And in the third one, a cube b square. So these are the terms that we are getting common. The next thing is to understand that we will divide this entire expression with the lowest power of a. So in the first expression we are getting a cube. In the second expression we are getting a square. And in the third expression we are getting a cube. So what is the lowest power over here? You can see that a square is the lowest power of a. So we are basically dividing it by a square. So if we divide it by a square, the term that we are getting over here is a, and over here we won't get any a containing term. Over here we will get a over here. But what about b? B will remain as it is. So let me write b cube over here, similarly b cube over here, and b square over here. So first thing is to divide it by a. The next thing is to divide it by the next term, that is b. So for dividing by b also we will figure out the lowest power of b. In this particular case, the lowest power of b is 2 over here. So we will divide this entire expression with b square. So if we divide this entire expression with b square, we will get a in the first case as well as we will get b in the first case, because b cube divided by b square will give you b. In this case we will again get b, because b cube divided by b square will again give you b. And in the third one we won't get any b containing term, because b square divided by b square will give you a only. There will not be any b containing term. So we understood that these two terms are common. So we are going to write this in the solution part, and then we will give the bracket. That means basically these terms are present outside the bracket. The next thing is to figure out what are the things present from the first expression that should be written inside the bracket. That means that is not common. So from the first expression we can see 9 is present. So we will write 9 over here, and over here AB is present. So we will write AB over here. So from the first expression we got this 9AB, that is not common, that cannot be taken out, common over here. The next thing is to figure out about the second term. The second term is 6. So we will write 6 over here, and over here we will get b. So let me write b over here. But remember not to forget the sign of that expression. The sign is negative, so we will write negative over here. The next thing is 25, that is present in the third term. So we will write 25 over here. Similarly, we will get a over here. So we will write a over here. That means we are basically getting 25a as the term that cannot be taken out, common. So this is the answer of your question. So method is very simple. We are just following the LCM method and we are getting the expression over here. I hope you understood this question. Let us discuss another question. Now let us understand this question. Now in this question, the first part is given that 14a minus 3b whole cube, and the second one is 21pa minus 3b. So first thing is to understand what we can take common. So we are basically using the LCM method, but as we have already discussed many questions related to that LCM method, let us directly do this question without the help of LCM method, because we need to practice those things also, directly doing the common part. Now in this particular case, let me write the solution over here. In this particular case, we can see that 7 is common in both the terms. So let me write 7 outside. So next thing is to understand that what is the next thing that we can take common. So we see that p is present in the second expression, but p is not at all present in the first one. So we cannot take p common because p is present in only one expression. So what about the next thing? The next thing is to understand about the entire expression a minus 3b. So this a minus 3b, the power over here is 1 and the power over here is 3. So we have already discussed that what we will see, what we are going to take common. We will take the lowest power. So in this particular case, we are going to take a minus 3b whole to the power 1, because the lowest in these two cases is power 1. So what is left from the first term? If we have already taken 7 common, we are left with 2 over here, and we are left with a minus 3b whole to the power 2. Why power 2? Because this is power 3, this is power 1. If we take power 1 over here, we will be left with power 2 over here. So we are basically getting this entire expression. And what about the second one? In the second case, since we have already taken 7 common, we are left with 3 over here and then p over here. So what about this one? Since we have already taken a minus 3b common, we are not left with any expression over here, that is a minus 3b. So we are basically left with only 3p in this case. So what we are going to do next? The next thing is to open the bracket. So over here 7 a minus 3b, and in this case we are just going to apply the formula that was present in the chapter expansion. So a minus 3b whole square. What is the formula? The formula that we are going to apply is of a minus b whole square formula, that is a square minus 2ab plus b square. So we are basically applying this formula over here. So let us do that. So let me apply the formula. This would be a square. Let me put a first bracket, a square minus 6ab plus 9b square, and there would be a minus 3p over here because this is the second expression. So let me open the bracket over here. So the answer would be like a minus 7 into a minus 3b, and in the second case we will get 2a square minus 12ab plus 18b square minus 3p. This is the third expression. So this entire thing is the answer. This cannot be further factorized. We cannot take anything common from this one. So I hope you all understood how to do directly. We just need to figure out what are the terms common and we just take that outside the bracket. So let us understand one more question in this case. Now let us understand this question. Now in this question we can see that there are 3 expressions, the first one, the second one and the third one. Now what we can take common? So let us first think what is present outside the bracket and see that whether they are common in any of the expression or not. In this particular case we are seeing that x is present. in this one y is present, and in this one z is present. So we cannot take any terms common because each and every term is having different terms outside the bracket. So we cannot take anything common. So what about the terms that is present inside the bracket? So inside the bracket, the terms that is present is x square plus y square minus z square. Over here, minus x square minus y square plus z square. And over here, x square plus y square minus z square. Now many of the students generally have an approach that as soon as they see bracket, they will open the bracket and then they will multiply the entire expression. That means they will multiply this x with x square, similarly x with y square and x with z square. And they do this with all the three expressions, and after that they think that let us take anything common that is present in these terms. So let me tell you, to those students, those who are thinking like this, that we need to open the bracket and then we are going to take common. For them, let me tell you that if you open the bracket, we are actually getting 9 different terms, and figuring out what is common from those 9 different terms is very difficult. So for them, let me tell you that instead of opening the bracket, you should think that whether there is anything common that is present inside the bracket also. That means that over here we are getting x square, but over here as well as over here we are getting the same term, that is x square. Similarly, we are getting y square over here. Over here also we are getting y square. Over here also we are getting y square. And you can see that z square is also present in all the three expressions. But we cannot take the terms individually. We have to take entire expression as one single term. But if you want to take these things, you have to think that what is the sign of these expressions. Over here x square is positive, but over here x square is negative, and in this one x square is again positive. Over here y square is positive, y square is negative, and y square is positive. You can see that the expression of the first one and the expression of the second one is entirely same, but in the second expression, if we just take negative common, then we will get the same expression. That means that if we keep this thing as it is, if we take negative common, so this x square that is negative will obviously become positive. Similarly, this y square that is negative will always become positive, and this z square that is positive will become negative. So we are basically getting minus z square over here. Similarly, minus z, x square plus y square minus z square. So we are getting the same expression in all the three terms. That is x square plus y square minus z square. Now the next thing is to take that entire expression common. So we are getting x square plus y square minus z square common. So from the first term we will get x, from the second one we will get minus y, and from third one we will get minus z over here. So this is your answer. I hope you all understood how to proceed with these kind of questions. Instead of opening the bracket and multiply the terms, you need to figure out that what is present in these terms that we can take common, either by taking any sign over here, that means a negative term or a positive term, and then figuring out whether there is something common in between these terms or not. With this, we understood the common method, that means the terms that we can take common. In the next class, we are going to discuss few more questions that is based on the different method that is present in the case of factorization. So let's meet in the next video.